La siguiente presentación estará a cargo de Chris Oesch de GBR Pfeiffer, quien nos hablará sobre sistemas innovativos para los molinos verticales de rodillos, especialmente con multiaccionamiento.
So, good afternoon. Unfortunately, I'll do the presentation in English. My Spanish would be very bad. So, I'm from GBR Pfeiffer, and we'll present today two mills, two projects. One, a swing mill, and we'll explain the swing mill, and the second one is the large MVR mills for high-capacity grinding of mills. So, if I were to just give you a company history, GBR Pfeiffer is in business since 1864, so basically next year we will be 150 years old. We started supplying equipment to the cement industry in the 1890s, and the first mill in 1894. So over the years we have developed the MPS mill, and the first MPS mill, or the first vertical roller mill for clinker grinding, was in 1979. The mill was installed in Germany. In 1994, we have updated or upgraded the mills to the B series, the MPS B mills. And in 2000, we opened Pfeiffer India. 2005, Pfeiffer America, from where I am. And in 2006, the first MVR mill was installed and in operation. And 2007, the MultiDrive for the gearbox on the large mills was installed. And in 2011, the largest mill in the world was installed or purchased for installation in Brazil. This is at the Barroso plant, we will see later. So the first mill I will present is what we call the swing mill. This is a mill in operation in Colombia. And what do we call about the swing mill? The mill is designed with our standard mill to grind both raw materials and clinker grinding in a common mill. The advantages, of course, is that the mill needs no mechanical adjustments. It can be all done online, the changeover from the raw material to clinker. No downtime, no opening of the mill, automatically done in the control room. The advantages, of course, is that in one mill, we are able to grind the different materials. Thus, the capital cost for a client who may be either starting out with a kiln and having the intention of upgrading in the future, can reduce his investment cost, or just to keep the investment cost down with a single mill instead of having a raw mill and a clinker mill. So you can have a look at the mill that is in installation in Colombia. The raw material is running at 170 bar, and the clinker is running at 215 bar. The adjustments, of course, the accumulators have to be adjusted. This is done automatically. It is online, and the client can do it from the control room. Again, you can see the grinding forces between the raw and clinker. Of course, clinker needs a higher grinding force. Again, this is done through the hydraulic system automatically. And the only other adjustment you make is in the classifier speed. For raw material, a coarser grind, you are running at 105, and for the clinker, to obtain the finer grind, you increase the capacity to 189 RPM. Again, no additional settings or mechanical adjustments in the mill itself. So here you can see the operating of the mill, some operating data. This is some results that were taken after the mill is already somewhat worn. We have 28 millimeters wear on the roller tires and approximately 19 to 20 millimeters wear on the table. The mill in clinker is grinding at 37.6 tons per hour and a fineness of 4200 Blaine. Of course, the power consumption, 23.9, and if you have a look, the airflow at 92,000 normal meter cube per hour. Now you look at the figures for the raw material, we're running at 60.4 metric tons per hour with a fineness of 12% on 90 micron, and a reasonably hard raw material, 14.8 kilowatt hours per ton. And interesting, you see the airflow is very close to the clinker at 87,000 normal meter cube per hour. So again, you see the adjustments between the raw and the clinker are very minimal. It is really hydraulics and classifier. In both the materials, they are somewhat harder than was anticipated, but the mill is still obtaining the required capacities and the guarantees as put out by the client. Here you can see the mill during the erection at San Marcos, and the mill when it's complete erection in the process. We are feeding both the clinker and raw material through a single feed point, only alternating from one conveyor belt to the other. Here you see the mill and the mill door open. So we have a single access point for maintenance, an advantage with the FIFO mill. The single access point means that the mill can be put in a very tight corner or area within the plant. We do not need a lot of real estate for maintenance. So now I'll present the second portion, is about the cement plant's larger capacities. And the MVR mill that we have developed, and it is in operation already, and several of the mills already been sold. So the whole motivation of this is that the cement plants are getting larger and larger in their capacities and needing a larger vertical roller mill both for raw material and for clinker grinding, as opposed to having two raw mills or 2 or 3 clinker mills. The FIFO have developed a mill that we could go with a single mill for raw material and a single mill for clinker grinding. So during the earlier years, we have developed this mill to go up to 12,000 kilowatts installation. And a little bit later, I will show you the concept of active redundancy, how we are able to still keep the mill operating in the case of a roller failure or a gearbox failure. So we'll first look at the roller suspension. You'll see the 2 rollers are fixed to a single pedestal, and the pedestal includes the roller, the rocker arms, the swing points, and the complete hydraulic cylinder system. You'll also notice that the hydraulic cylinder that is used for operating the mill is also the same cylinder that will be used for maintenance of the mill, meaning you do not have to bring in any maintenance equipment. It is already there. The advantage as well is that this mill is running on a parallel gap, so you have a very smooth running and evenly transmitted wear. We also are able to take the rollers and swap them round after a wear life to extend the wear life of the grinding elements. Yeah, again, you see how the swing out is done with the working cylinder. So the second part that makes the mill of these large capacities able to operate in this active redundancy is the MultiDrive system. The MultiDrive system basically is a large ring gear around the table of the mill, driven by a range of external gearboxes and motors. We may have from 3 up to 6 of 3 different modules, and from this we can go up to 12,000 kilowatts installed power. Yeah, you can see now the active redundancy is, if you have a look, you can see here we are able to remove a single gear drive unit and 1 roller, and then the mill can continue to operate. In the case of, say, a large mill, like here you see a 6-roller mill, you'll be able to continue operating the mill at basically 80% of its maximum capacity, and the gearbox, because it has a safety factor on top of it, will allow you to use the maximum power consumption that you need for the mill. So this allows you to take any single roller or any single gearbox out and continue operating the mill at its full capacity. And this is required more and more with this active redundancies, where the plants want to rely on a single mill, but do not want to have the risk of a mill failing and then losing their capacity. So what has changed between, say, the MVR mill and the design of the MPS mill? Basically, the process stays the same inside both mills. The airflow, the grams per meter cube, and the classifier systems. This has remained the same. What we have changed is a capacity range. The MVR mills are specifically designed for high capacity kilns and throughput through the mill. we have increased the number of rollers. Because as the capacities have increased, so also the rollers, the number of rollers are increased so that you don't get an oversize in a, let's say, a limited number of rollers within a mill. The roller suspension system has been changed to allow for a flat table and cylindrical rollers inside the mill, thus keeping the parallel gap. The MultiDrive is ideal for, especially for clinker grind or various types of mixers, slag, clinker, and all the mixers that come with it, as it is already automatically a variable speed drive unit. So they can also adjust the speeds in the mill. And of course, the MultiDrive giving us the redundancy that we can continue operating the mill at full capacity even if there's a missing gearbox. So if you have a look at the mills that are in operation already, we have a MultiDrive that is in France, is in operating. There is the MVR, is operating in 3 plants already, where the large one, which we'll show you a little bit more information on now, is the one in India, the 5.6 meter table diameter, grinding over 320 metric tons per hour of clinker in a single mill. So originally we have installed 4 gearboxes of 1650 kilowatts each around the ring gear. The mill is a 5.6 meter table diameter. The rollers is 2.83 meters in diameter. And we have been requested to operate the mill in 2 different materials, PPC and OPC, at 320 tons per hour and 310 tons per hour based on the different blanes, 3500 blane and 3000 blane. This is a reasonably coarse or low blane figures, but it is in the Indian market standard. And therefore, you also see the kilowatt hours per ton at 17.4. So here we can also see the rotary valves that has been installed. It is a heated rotary valve from the inlet gases to the mill, feeding the large mill. Here you see the MultiDrive in erection, and the mill stands around it. So each gearbox around the main ring gear, and then the table is bolted on here. Of course, an additional advantage of this type of gearbox is that the mill itself is much lower, because you do not have to install a gearbox under the table. Around it, you see the 4 pedestals that are waiting for the rollers to be added on. So the mill housing is installed, connected to the stands, and the grinding table brought in and fitted to the gearbox. Here you can see the roller assembly being installed into the swing arm, and then will be swung into the mill itself. The housing and the separator installed. There you can see the separator is completely assembled and will be put on top of the mill housing. And yeah, of course, you see the mill inside the building, connected to the rest of the plant with the ducting, and of course all electricals and other auxiliaries such as seal, air, gearbox lubrication, etc. installed. The bag filter, being a large bag filter for such a high capacity, is installed in 2 rows or 2 banks. And of course you see here the whole plant with the mill building down at the bottom here. So a closer look at the mill. Single inlet for hot gases, the 4 rollers around the table, the seal air, the foundation, and the gearbox at the bottom here. Again, as I said, the mill is a lot lower, is reduced in height, because we are able to eliminate the large gearboxes that you require for under the mill. So after in operation, the mill has achieved, you'll remember we had to achieve 320 and 310. We have achieved 360 at a higher blane, 3700 blane, and 320 to 350 up to 4200 blane. And the power consumption was much lower than expected. So here you have a single mill that is grinding over 360 tons per hour. So here you see the parallel gap of the roller mill, the outside dam ring, the nozzle rings, and of course the grinding table. So currently we have several of these mills under execution. The kilns, as we said, are getting larger and larger, and clients are looking more and more for a single mill. So there are 2 raw mills that we cannot disclose the client at this point, but these 2 mills are in the fabrication point and will be delivered later this year, the first mill. Port Kempler is now in erection, and this mill will be probably in operation at the beginning of next year. This is a plant for Holcim, and it is grinding, you can see, SEM 1 or slag, up to 208 tons for SEM 1. This is also operating with a MultiDrive, so it has the active redundancy, and it is a 6-roller mill with a 6-meter table diameter. So in India, we have additional 4 mills being delivered to Sri with a 6-meter table diameter and 6 rollers. This is run with a standard gearbox, or the planetary gearboxes, as you know, of 6,300 kilowatts each, and then an additional raw mill with 6 meters and 6 rollers. And the mill at the end here, this is the one that I think everyone is aware of. This is a project that will go to Barroso for Holcim in Brazil. This is the single largest mill in the world at the moment. It has an installed power of 11,500 kilowatts. It will be producing up to 450 tons per hour of a mix of clinker and slag in a single mill. This mill already has been delivered to plant, and the erection is in progress, and we're not exactly, I don't know the exact dates, but it should be towards the end of next year that this mill goes into operation. So this also has an active redundancy. You can see it has 6 gearboxes of 1,920 kilowatts each, giving us the 11,500 kilowatts, and we'll be grinding 4,300 to 4,800 blane. So to keep it nice and short, thank you for your attention, and here you can see the typical plant layout of such a large machine. Thank you.